Estimation and confidence intervals. In statistics, the process of using sample data to calculate a number that can be used to represent an unknown population parameter is called estimation. The number that we obtain from a sample mean is then called a point estimate, or simply an estimate of the population parameter. A point estimate is a single value estimate for the unknown value of the population parameter. In order to find a point estimate, you must have a definite target population, then identify the variable of interest. Collect a sample from the population, then compute the point estimate from the sample. Example number 1. In a city, 5,238 private cars are registered. The owner of the gas company wants to know the proportion of these cars that use diesel. How do you propose to find the point estimate of the population? For the solution, population of interest is 5,238 registered private cars. Variable of interest, type of fuel, non-diesel or diesel. Parameter of interest, population proportion, in symbol P, of the 5,238 cars that use diesel. Number of samples, n is equal to 30 or more, may be selected at random. From this sample, we can get the point estimate given by the number of cars that use diesel, which is x, divided by n, or proportion is equal to x over n. Using a point estimate to get an idea about the value of a population parameter poses a degree of so much uncertainty, since we do not expect the estimate to be exactly equal to the parameter. This leads to the alternative using of interval estimate. What we look for are two numbers between which the parameter likely lies. A confidence interval for a population parameter is an interval estimate with an associated confidence that contains the unknown parameter. We call 1 minus alpha the confidence level or degree of confidence of the interval, where alpha is the significance level. So 95% confidence level means 95% of the intervals would include the parameter. Now, when population mean is estimated using statistic sample mean, then the sampling error is the difference of the sample mean minus the population mean. This difference changes from sample to sample, and so our interest is to calculate the maximum value of error in symbol E, which is defined as follows. The margin of error E is the maximum error of estimate given by the formula E is equal to z-score of alpha over 2. So this is our alpha over 2. And this one is the confidence level 1 minus alpha times population standard deviation over square root of n. So n is the number of samples. Example number 2. The principal of Manda High School wants to know the math proficiency of all the students in his school. Instead of administering an examination to all students, he decided to take a random sample of 60 students and got a point estimate sample mean, which is equal to 70.28. With 95% confidence level, find the margin of error for the estimation of the mean of math proficiency of all the students of Manda High, assuming that the standard deviation is 1.25. For the solution, the z-score that corresponds to 95% confidence level is 1.96. We'll get this using table of z-scores or Microsoft Excel. This means that 95% of the area under the standard normal curve falls within negative 1.96 and 1.96 positive. So margin of error is equal to z-score times this one, so 1.96, and then 1.25, our standard deviation, over square root of 60. So 60 is the number of samples. So 60 students, which is equal to 0.3163. This means that the principal can be 95% confident that the margin of error for the estimation of the population mean is about 0.3163.